Oh, I got it. I'm gonna call an audible real quick. This will be I hope a 1 minute detour, but just as I'm sitting here, I thought I probably should have said this and I didn't put it in my plan here. So I'm just gonna point this out. So if I had an equation like x over m minus 3 over m equals 11 over m. Sorry if that like freaks you out a little bit, but don't be bothered by this. The only point I'm trying to make with this example is that the bottoms are the same. And so what I want you to take from this first example is this. Listen very carefully for about 15 seconds. Give me 15 really good, full, open ear, open brain seconds. You ready? In an equation, if the bottoms are all the same, then you can just take the bottoms away. So in a math problem like this, you would look at it and think, this looks intimidating because like a denominator of m, I don't know what to do. But the fact of the matter is that they're all over the same thing. And so today we're going to go on a journey where we'll obviously have to change the bottoms. But if the bottoms are already the same, then you don't have to worry about it. All you essentially do is take the things off the top, copy them down. So we have an x minus a 3 equals an 11. And then in a case like this, often what you're going to see throughout the day, the next couple days, is that the equation that pops out is going to be pretty elementary, like simple. So all I'd have to do here is add 3 to both sides, and then I could say that x must equal 14. So again, the moral of the story is that if the bottoms of the if the denominators of the fractions are the same, then the bottoms become irrelevant. And that's going to be the mission is can I make the bottoms the same so that I don't have to consider them as fractions anymore? Okay. And if you want an explanation as to why that is, if you don't want to just take my word for it, you could easily make a case with anybody that you're just going to take this whole equation and multiply the whole thing by m. Because that's legal. Like we've been doing that since probably 6th or 7th grade. And so like you see, if you multiply by m, the m's cancel. If you multiply by m, the m's cancel. And if you multiply by m, the m's cancel, right? So it's easily sellable as to why this is. It's not black magic or witchcraft or anything like that. Okay. All right. So let's get to what I actually wanted to do today. So I'm going to give you 5 examples, and in none of these instances are the denominators already going to be the same. So our first one is x minus 2 over x squared minus 2x minus 8. And then we're going to subtract 1 over x squared minus 2x minus 8. And we're going to set that equal to 2 over x minus 4. So going back to the first example, the little warm up, you can see here that we're not in a position to just drop the denominators, right? So step 1 will be the same as it was in the last little baby unit, the last quiz you took, and that is what is the LCD? And you should be pretty expert level at this by now. What is the LCD of this entire equation? X minus 4 times x plus 2. And that revelation would, of course, come from having factored these existing denominators. Don't factor any numerators at any point until the end. Okay, just hopefully you got that from the last unit. Don't factor tops, just factor bottoms. And so this one and the other one are both x minus 4 times x plus 2, right? Factoring 101. And then you can see that the denominators all need to be x minus 4, x plus 2. So as we go through this equation, we think about who do we need to fix? What's the answer? Yeah, the last fraction needs fixing. I hope we all agree. So first fraction is fine. He's got the LCD. Second fraction is fine. Third fraction, not fine. So we're going to take his top and his bottom and multiply them both by x plus 2. And once you perform that operation, you now have 3 matching denominators. And as was discussed a few minutes ago, the bottoms no longer have any relevance. Okay. So what's going to happen now is you're going to wind up with an equation that is just consists only of the stuff in the long purple dinosaur caterpillar thing or whatever that is, right? So nothing else matters. So we're going to wind up with x minus 2 minus 1 equals what? 2x plus 4. Right? We shan't forget the basics. That's kind of always the rub with math once you get into high school is that, we tend to sometimes overlook the simple things. So don't do that. And then again, boom, look, it just went from like an 11th grade looking math problem down to maybe a 7th grade at hardest, right? It's just now a linear equation. And your training would tell you that this is not a move everything to one side situation. That thinking is reserved for quadratics. This is a basic just separation problem. And so we're going to move our x's to one side, giving us 1x. And then we're going to move all of our numbers to the other side, giving us -7. And we're done. Now, you will be required to check for extraneous solutions. This is another one of those annoying units where you can get answers that make bad things happen. So I'm going to scroll back up and ask you a question, a math question. Looking at what you see, there are two answers that if you got them would not be allowed for reasons that I don't really think we've discussed much in recent weeks or months. Can you think of an answer that would make me look at this equation and say, not going to work? If you can't, I'll tell you one, but I want to see if you can come up with one. I'll tell you this. If down here in this purple egg, if we had gotten x equals 4, we would have to cross it out. Why? What equals 0? No, it doesn't. I think I don't remember this. I always refer to this, and honestly, I've not gone and looked at it in a long time. Across the hall, there's a poster. There used to be a poster called the 10 Commandments of Math. And I believe number 1 in the 10 Commandments of Math was thou shalt not divide by 0. I'm pretty sure that that was number 1. I need to freshen up on my 10 Commandments of mathematics, but thou shalt not divide by 0. And so let's think about this for a second. Follow my long green arrow. If I took 4 and I put it into any one of these denominators, like say right there, what is 4 minus 4? And what is 0 times 6? And you see what you've done is you've created a situation where you break commandment number 1. You tried to divide by 0. 4 would be an answer that would not be okay. You might get something like that, and then it's your job to just say, no, you can't stay. And you're used to this. This ain't your first rodeo. If it's a bad answer, you cross it out, right? What would be the other answer now that you understand what I'm going for that would have made me cross it out? Say again. Correct. Had we gotten x equals -2, our logic would have been exactly the same. Because again, if I take -2, and I'm just going to go a little shorter route this time, and I put it like right there, what's -2 plus 2? 0. If you can make any if you can make any of the factors in the bottom equal 0, it's no go. Because what the other factor is doesn't matter because anything times 0 is 0. So what you're going to look for with your extraneous solutions is, did I break commandment number 1? Okay. But in this case, do we have any issues with -7? I don't think so. -7 is probably going to be just fine. So he can have himself a box. Same expectations as before. Our answers do not just sit out there buck naked. Okay, they are to be dressed with either a box if you like them, or a cross if you don't. But let's try again. Any questions there? Okay. Next one, let's do x squared minus 9x plus 18 over 4x equals x minus 1 over 4 plus 1 over 2x. Take it easy there, Sarge.
Oh, yeah.
Oh yeah. Um, First thought is, what's the LCD? What are we thinking? If you say 4x, then that tells me you have been listening quite well now for a couple of weeks in my class. Good. All I need is a 4 to cover the 4, and the 2. And then all I need is a single x to cover this x and this x. I don't need any more. There's a reason we put that L in the LCD. All right. We don't want just AOCD, any old common denominator. We want the smallest one possible. 4x does the trick. So we just go through like we have before and just ask ourselves with each fraction, what do you need? So let's point to the first fraction. What does he need? He's good. So I can just copy down all of his parts and pieces. X squared minus 9x plus 18. And if you're thinking of factoring that, you're still not listening. Stop trying to factor the tops. Okay. They're not there for you to factor. They later, maybe, when everything's put together. Let's talk about the second fraction. What does he need? Good. So we're going to take what already exists on the top, and we're going to multiply pre-existing top by what the bottom needs. And so I'm going to put equals what the bottom needs times what the top already has. I'm going to change this one x to yellow just so you can see that x is the new guy. He's the multiplier. He's the I had to multiply by this guy. Okay. On to the third fraction. What does his bottom need? He needs a 2 to get multiplied to become the 4x. And so the pre-existing was a plus 1. I don't really think I probably need to show work on this one. If you already have a 1 and you multiply it by 2, you get 2, right? Notice again, I'm not even acknowledging the bottoms because they're gone. Once I made them the same, they were going to be redundant, pointless. So just kind of kill them as you go. And poof. This is not a seventh grade equation, right? So some equations that spawn will be high school equations like this, a quadratic. And maybe the quadratic terms will cancel. Who knows? Let's find out. So step one, now that we've made it through the first hurdle, is just let's clean up some messes. So we have x squared minus 9x plus 18. What's this right side going to be? X squared minus x plus 2. Next step.
Or
Listen, I would feel guilty if you guys graduate next year from Burns High School and on graduation day I put an equation like this in front of you. I won't do that to you on graduation day. But if I did put an equation like this in front of you and you said, I don't know, I would feel like I robbed you. Like maybe they should consider replacing me with someone else. All right. I would like you to speak to me. How do we solve this equation? The x squareds will cancel. Now we're having a conversation. Thank you. We have to move the x squareds to the same side. And in the process of doing that, if you subtract x squared from both sides, you can see clearly that they are gone. And that's a huge deal because that immediately transforms this equation from high school to seventh grade. Just boom, in the blink of an eye. Because once the quadratic terms die, it's just a linear equation. And then we go back into our training. X is to one side, numbers to the other side, business as usual. So we just have a choice to make now. Would you guys prefer to move like X's to the right and numbers to the left, or X's to the left and numbers to the right? I, for one, couldn't care less. Sure. Just kind of par for the course here. So let's add the X across to both sides. Look at me showing my work, right? And that's going to lead me over here with negative 8X's. And by nature, like this isn't up to us anymore now. Who has to now move? The 18, right? The X, you kind of had a little freedom of choice there. But once you commit to X's go to the west, constants must go to the east, right? With linears, we don't want everything on one side. So we separate. We wind up with negative 8x equals what's 2 minus 18? And we get x equals 2. And again, our responsibility at this point in time is to just to go back and see if he's going to cause any problems. So let's head back up and see if 2 is going to be an issue. Is 2 going to be an issue? No, got no issues with that, right? So we're going to put a box around that guy. If you want to be really thorough, You can always check them, like really check them. Go back and do all the checking, and plug it back into all the X's and just kind of vet it and make sure that it checks out. But that'll be good for now. Yeah, let's go again. 3x minus 3. I tried to keep these different and representatively like a good sample of what you're going to see on your assignment today. Again, can't go anywhere until we answer the red question. Without that, you're just never going anywhere. What's the LCD? Yeah. How can you prove that to me? Like, because there's going to be someone in the room right now who doesn't know how you got that. They're going to write it down, but they're not going to ask. How can you prove to me that the LCD is x squared minus 6x? Right. Kind of more what I was hoping you'd say was that if you factor this one down by pulling out an x, you can actually see it. You can see with your own eyes that if I GCF an x out, it is quite literally x times x minus 6. And then this one is x times x minus 6. Right? And then you can see with your own eyes that what's missing from the third fraction is the x, right? So it might be beneficial to think of the LCD as x times x minus 6, but I've got no issues with the multiplied out version of it as well. So let's run through the fractions and ask ourselves the inevitable question. What's this guy missing? Nothing. He's fine. So we just copy down his top. And then we're going to put plus 1, get this ready to go. Second fraction, what's his bottom missing? So he's good. Third fraction, what's his bottom missing? So we're going to multiply the top and the bottom both by x. And on the right side of the equal sign, we're going to have 5, but now times x. And for the third straight example, fourth, technically, we've got ourselves a very fundamentally simple little linear equation to solve. Okay. The way my brain works is I like to keep my x's positive. I'm kind of OCD about it. So instead of asking you this time, I'm going to move the x's to the right to control them and make positive 2x. I like that better. I've always liked that better. Right and left mean nothing to me. Okay. So I get 2x equals what's negative 3 plus 1? What's x equal? Okay. And again, all we're going to do is just go give it a test. -1, head back up. Do you see any issues with -1? No, not even close. So we're good. So you can box that little sucker up. Any questions so far? Okay, let's keep on keeping on. Two more. Two more examples in our last math lecture of the year. For some of you, if you don't take any more math classes, your last high school algebra lecture ever. So enjoy. Two more. I mean, I could do more if you want. If you get sad. Was that you, Landon, just laughing? I'm going to ask you this question, but this time I'd like you to answer it a little bit differently than Parker did last time. I'd like a kind of more in-depth answer. Can anyone tell me, just looking at this, what the LCD is? Thank you. That's a big ask, by the way. What should we do? It's my second favorite F word. You should know this by now. Of course, let's factor. Listen, if you got denominators staring at you that just they're waving at you, they're literally waving, saying, could you factor me, please? Like, don't fight it. Don't be stubborn. Let's factor. So let's start with the red egg. How do you factor that? It's going to take a couple of steps. Say that again. Good for you. That guy's still waving at me going, hey, nice job, but I'm not done yet. Come back. Let's go again. Round two. What's next? Good. So you factor the trinomial that's left, and you wind up with x times x minus 4 times x minus 1. Can't stress enough. You want to see all of the parts and pieces exposed so that you can make a judgment call later on as to what do I need for each fraction. And this one, he's got a lot, man. So instead of writing his bottom as that x cubed nonsense, I'm going to change the bottom to look like that. Same question with the middle one, the second one after the one after the equal sign. What's his real identity? This guy. The more you talk to me, the quicker this will go. What can I do to factor the red egg? Pull out x, leaving x times x minus 1. Okay. So, but you got to get that GCF out. Remember, we're not losing any pieces. We're just reorganizing them, rewriting them. Okay. Factoring isn't about changing things. It's just changing the way they look. And so now our second denominator reveals his DNA and says, these are my parts. And then the third fraction, you obviously can't factor, but what having it like this is hugely critical because now we can answer the question of what is the LCD and what is the LCD? Just scan through here and tell me what are all the parts and pieces that I need? What's something I need? Yes, I need an X. Like, let's get that out of the way. You cannot build either of the first two denominators without an X. And then the first one says basically you need all three of these pieces up here in the corner. I hope you can see those. X times x minus 4 times x minus 1. You need all of those to build me. And then I mean, those pieces cover everybody, right? If I put those three pieces in a little bag or a box and I handed them to you, you could make the second one and you could make the third one, right? So we found our LCD. So here we go again. What's he missing? Oh. Nothing. So we can just write down 1 equals. Nice. See how methodical this is? We don't veer off course with this. Like this is rinse and repeat. Find the LCD, make it happen over and over again. What does the second fraction's bottom need? He's missing the x minus 4. So I'm going to take his pre-existing top, and then I'm going to multiply it by what its bottom needs. This ought to look pretty familiar from last week. And then I'm going to put minus 1 and wait. Now, what is his bottom missing? This third fraction, he's missing 2 pieces. What are they? Okay. Yes. So he says, I need you to multiply me by x because I'm missing that, and by x minus 1 because I'm missing that. And now the construction of this is done, right? The bottoms all match. Everything's good to go. If I were working by myself, I probably wouldn't have put x times x minus 1. I probably wouldn't have even put the 1 in front, right? I just thought I'd be really thorough with this. So again, the things that I'm writing in yellow are the things that got multiplied in to satisfy creation of an LCD. So yellow guys are the multipliers. And now no more bottoms. It looks to me like just an algebra problem. So let's clean house. So we get 1 equals. What's the answer to this? The thing I just underlined. Boom. And I would caution you, having graded your quizzes yesterday, I would caution several of you to just pump the brakes a little bit. Careful. What's the answer to the green underlined thing? I'm gonna go off to the side here a little bit and change the way this looks. I'm gonna rename it as negative x times x minus 1. I think getting that 1 out of there might kind of clear the clouds from your vision. I'll try that again. Negative x squared plus 1x. Good. Be careful. These little negative distributions can be little boogers. Notice anything? Right. Again, we're just getting lucky with this, right? We're just getting more x squareds that cancel. So this is like, cool, thanks. And so obviously, since they're on the same side of the equal sign, we don't do any of that plus x squared twice. I hate it when people do that. They're on the same side, for God's sake. So x squared and minus x squared just go away. And then we're left with just a bunch of terms. So I'm going to take these two yellow circled ones and just put them together to make 2x. And then the 20, I'm going to say, you, sir, got to go. So I'm going to add 20 to the other side and get 21. And then I'm going to divide by 2 and get my answer of 21 halves. For the purpose of checking this, you could think of it as 10.5, 10 and a half, whatever. But again, what we're looking for is any egregious, obvious breakings of laws. And if you take 21 halves and go back to the beginning and put it up in there, are you going to see any issues with that? Again, we're not seeing any of the normal, the law breaking that might come up. What are the three answers I could get? Let's see if you're paying attention. What are the three answers I could get that I would have to cross out? Give me one of them. Say again. If I had gotten x equals 4, I would cross it off. What else? If I had gotten x equals 1, I would cross it off. And the third one, you guys are amazing. 0. Don't forget that if you have a free range x, anything that's free rangey like that, an x, 2x, 3x, something like that, 0 is the bad guy there. Okay, but we didn't get any of those, and so we're good. So you can box this little guy up and on to the last one we go. Our last math problem of the year in this format, which is kind of exciting. But again, I could do more if you want. Like if you get the shakes, like I need some more math instruction, just let me know. I'll hook you up. I know a guy. Okay, tenemos que hacer primero. Actor, I love that word. Listen, if the thing I just circled in red doesn't make you think factor, again, I would take this on myself. I have failed you. I have just dropped the ball. I have not done my job well enough. That is just yelling at you. Factor me, factor me, factor me. What is he? Yeah, he's the difference of squares, the old classic x plus 4x minus 4. So it's kind of like out with the old, in with the new. And now the LCD should be wholly visible here. What is the LCD? Absolutely. Each fraction just says, give me one of each of those and I'm good to go. So uh, fifth verse, same as the first. What is the first fraction missing? Nothing. So we can just copy down his top x squared plus x. Nothing there. This second one, what's his bottom missing?
X minus 4.
X minus 4. And so I'm going to take the minus 1 that was already there, and I'm going to multiply it by x minus 4. Third fraction.
X plus 4.
Yeah. And so I feel like, and I don't know if you agree with me, it would be kind of silly for me to write equals 1 times x plus 4. I feel like we can just agree to just put that, right? Let's do it. Let's solve. No more fractions, no more rationals, just an equation, just a high school math equation. I feel like we should probably tend to this green egg first. High school or not, doesn't really matter. People still like to mess this up. So let's copy down the x squared and the plus x. What's going to be the result of the green egg? Negative x, change the sign for. Good job. Thank you guys for catching that. Well done. And now our training kicks in, and Again, we need to have our mind in two different places. If it's a quadratic, my training says to do this. If it's a linear, my training says to do this, like where I separate. This one clearly is a quadratic and it's not going to unquadratic itself, right? So our training kicks in and we say, let's leave x squared here and let's bring all of our x's to the other side, right? So tell me about these two that I'm circling in red. They're gone. And then if I just move Mr. Solo over here, I'm just left with minus x. And then tell me about these fours. They're going to cancel. So we're left with x squared minus x equals 0. What do we do? Thinking of a word that starts with F. And it's not it. Hey, factor, pull out an X. Remember, factoring does not mean build two shells. Yeah. Factoring can mean a lot of different things. And in this case, factoring means pull out an X. So I pull X out of these, leaving behind X minus 1, set it equal to 0. And I now have two factors. Therefore, I will have two solutions. What solution do I get from just lonely free range X? 0. You always get 0 from a free range, right? One of those monomial factors. And then how about this one, X minus 1? 1. Let's check and see if we break any laws. Let's go back to the very beginning of the problem and see if 0 or 1 are going to break any laws. So 0 and 1 are my two candidates. And going back to the beginning, see any issues? Yeah. You would walk away from this lecture thinking that you're never going to get extraneous answers. That was not intentional. It was just happenstance. So in this case, though, again, we don't have to cross anybody out. There's no lawbreakers here at all. Right, 0 is not going to cause any problems because the bottoms are not going to go 0, and same with 1. So they can both have boxes, and that concludes that. So you guys ready to do assignment number 50? Ready to rock and roll? We got 6 minutes today. 6 or 7. And then tomorrow will obviously be a work day. And then Wednesday we'll either continue or just do some more. What do I even want to know? Okay. Well, okay. You guys are crazy.